All right, so working in the laboratory, we're going to rely a lot on our balance, okay? The balance, we want to keep clean. We want to make sure that we are using it properly. It has, as you see here on the display, it tells us our mass in grams. We have 3 decimal places. Therefore, this number here is the number of milligrams. So if we have 0.1 grams, we have 100 milligrams. All right? When we weigh things on here, if we're weighing out a chemical, then we need to have a container which we weigh it in. Though that container we call a weigh boat, and we have a variety of them over here, different sizes depending on how much you're going to weigh out. So I grab myself a weigh boat, I bring it over here. I have 3 different doors that I can open. I don't need to open them all, depending on how I'm going to put this onto the pan. I want to be careful when I place things onto the pan not to drop them too hard or push onto the pan or disturb the pan. All right, I've placed the weigh boat onto the pan. I see a mass here. I'm not interested in that mass. I'm interested in what I'm going to put onto it. So therefore I can tear the balance, and now it'll say 0, and now it's ready for me to add some chemical of some kind. Okay? My chemical that I'm going to be working with here in a bit is called copper sulfate. All right? Let's go to the board here for a second and talk about what copper sulfate is. It's copper 2 sulfate, so that means that the copper, so it's copper 2 sulfate. And that 2 refers to the charge on the copper ion. So here's the copper ion. It has a +2 charge. The sulfate has a -2 charge on it. So 1 copper with a +2 charge is going to match up with 1 sulfate with a -2 charge. So that's going to be CuSO4. All right? So that's my copper sulfate, copper 2 sulfate. To determine if I want to weigh out a mole of the copper sulfate, I need to know the molecular weight, or the formula weight of the copper sulfate. I can do that by looking at the periodic table, finding out how much the mass 1 atom of copper weighs, how much mass 1 atom of sulfur weighs, how much mass 4 atoms of oxygen, right? So we have 1 atom of copper, 1 atom of sulfur, 4 atoms of oxygen. Add that all up, and that'll tell me the mass of 1 mole of copper sulfate, right? That's what we do in the lab, or in the classroom all the time. In the laboratory, you have to do something a little bit different, because when you go and ask for copper sulfate, you don't know if they're going to give you copper sulfate with or without water on it, right? And chemicals that have water stored with them are called hydrates. And this chemical here we see is called copper 2 sulfate pentahydrate. All right? And there's a couple ways to get around this. We can always look for the name, write down then how many waters there are, right? Find out the formula mass of this, and then weigh out that much to get 1 mole of copper sulfate. Or we can also almost always go to the bottle and look for the formula weight, which is on the side of the bottle. This formula weight here tells us how many grams are in 1 mole of this chemical. All right? So if I go and ask for copper sulfate at the stockroom and they give me copper sulfate monohydrate, I'll be able to look here and it will tell me the formula weight. If it's pentahydrate, I can look here and it'll tell me the formula weight. The formula weight will always be the same amount necessary to weigh out 1 mole of that substance in the bottle. Okay? So that's one thing to pay attention to when you're in the lab. Watch out for hydrates and determine exactly the correct mass that you need to weigh out to get 1 mole of the substance. Okay? So I'm ready to weigh it out. I need to get a spatula from my drawer. I have a couple of different spatulas I can use here. If I'm going to set the spatulas down, I want to find a clean place to set them down. Here's a paper towel I can use. So that way it's not going to pick up anything, contaminants from the tabletop. All right. Again, I have my weigh boat in there. The weigh boat's not touching the walls or anything. The walls, the doors all need to be closed, because if they're not, then just the air of me moving around the lab, or the air from the air conditioning, or doors opening and closing, is enough to change the mass and alter the sensitivity of the machine, the instrument here. So, if I'm going to add some copper sulfate onto this mass, this balance, let's say I want to weigh out 0.1 grams of copper sulfate. 0.1 grams of copper sulfate. I'm going to move this door and this roof out of the way. I don't want to add it from way up here, because when I do that, I have a chance of sprinkling out copper sulfate all around outside of the tray, which will cause a mess. So when I add it, I'm going to do something along these lines, where I bring it down nice and low, and then I turn it into the weigh boat. All right? I said I wanted to weigh out 0.1 grams of copper sulfate, and you see here that I have 0.186 grams. So I've gone over, which is very typical to go over. All right? With practice, you will try not to go over, because once you go over, that copper sulfate that you're over by should not go back into this bottle. If it goes back into here, then everybody who works with the copper sulfate increases the chances of contaminating this bottle every time they put their sample back. So what I do instead is I go get another weigh boat, and I can remove the copper sulfate that I don't want into here. And I can put the weigh boat back on. Make sure I put it approximately the same place, 1.27. I have a little bit more to remove. Okay, I go back. Now I'm at 0.080. So now I've removed too much, right? I don't go back into here to get my copper sulfate. I can go back here to get my copper sulfate. All right, with technique, carefully, I can move these doors out of my way. I can carefully add my copper sulfate onto the weigh boat, and I can watch the value there until I went over just a little bit too much that time as well. Let's see how far I'm over. 1.06, so I'm 6 milligrams over, so that's probably going to be okay for what I want to do. All right, so now I have the volume, the mass of the copper sulfate that I want here. This stuff here, again, doesn't go back into my bottle. If I can convince my lab partner or somebody else to use it, that's fine, but we don't put it back in the bottle, because we don't want to contaminate that for people who might be doing research or other labs. So I have my 0.1 grams of copper sulfate here that I want to make a solution out of, let's say. I can bring it over to my volumetric flask that I'm going to put it into. There's also generally around the lab a funnel over here at this desk. Let's see if we can find a funnel. Here's a funnel. I'll give it a quick rinse. All right. So I have my volumetric flask that I'm going to put the copper sulfate into. I can add it through the funnel like this. And I see that some got in there, some got stuck in the funnel, and there's quite a bit here that's still stuck, right? So I have to use a transfer technique. I grab my squirt bottle. That'll allow me to squirt down anything that's stuck here in the funnel. I can also squirt down anything that's stuck in the pan, in the weigh boat. I can also collect a lot of water in here to wash the sides. after I can verify that I've removed everything out of this tray and everything out of the funnel, then I can continue to fill this up to the mark with water. Or my solvent. I'm not going to go all the way to the mark because this, I don't have a lot of control where I stop, so I stop early, and then I use something that I have a little more control on to fill it right to the top, right to the line. So the bottom of the meniscus is right at the line. I have my stop cock there, or my stopper, and now I can turn it like this and get a good mix, holding firmly on the stopper, making sure nothing leaks out. All right, and there are a few crystals left. I want to be sure that I don't use this solution until it's completely dissolved, because if it's not completely dissolved, then it's not going to be the concentration that I think it should be. All right, so there I have a solution of copper sulfate that I made. After I'm done making the copper sulfate, or using the balance, I want to make sure that I leave the balance nice and clean for the next person. So get myself some paper towels. All right, and I want to clean up the balance. If there's any spilling around the outside, I'll wipe off that. I'll open the doors here, and I can remove the pan very gently by just lifting it up like this, putting it somewhere safe, and then using this as a brush to brush out anything that was spilled. I want to be sure that when I'm cleaning, I'm not putting any dust into this area, and that I don't touch this area or anything, even with the paper towel. When it's all swept out, I put this on gently, and then I close the doors to keep it protected. Any extra that I have, I'm going to sweep into some sort of a container, or if I don't know where it goes, I can ask the professor, or I can ask the TA if it's okay to throw this in the garbage. If it's not, then I'm going to put it in some sort of waste container, which is generally kept here in this hood. All right? So, we tear the balance, we measure out the amount of copper sulfate we needed, remembering that we need to look at the formula weight to determine how much copper sulfate we need, or how much of the chemical we need, to whether it's a hydrate or not. After we measure it out, we transfer it into a volumetric flask, or something else we can rely on. It's the volume to make a solution, and then we clean up after ourselves as well.